Alright, so for this first problem, what we're going to be doing is finding out Superman's X and Y components. We see that he's diving off a building or flying off a building. I'm not 100% sure why he's doing that, but so he's moving 100 meters at a angle of 30 degrees from the horizontal. So what I'm actually just going to do is I'm just going to redraw the picture over here. So he's going down like this. And we have our reference angle here of 30 degrees. And so when we're dealing with the vectors, what I want to do is think about the direction. So which way is Superman going? Is he going up and to the right, up and to the left, down to the right, or down and to the left? Hopefully you're saying, hey, you know what? He's kind of going down and to the right. Hey, so isn't he going to the right and downwards? Alright, so we just drew in our two component vectors. So let's call this component vector x and component vector y. Alright, and what's the next step? Think about this. What do we do now? Well, we have to identify the different parts of the triangle. So what does this 100 meters represent? Hopefully by now you're saying hypotenuse. If you're not saying that by now, go review the other videos. And what about the y? What is that telling us? Well, that is our opposite side, right? And over here, we have our adjacent side. Okay, so we're going to just treat this like we actually did before. Let's solve for each one of these. What I want to do is, being that we have our hypotenuse is our given information, we're obviously going to be dealing with that. So one of these two equations, which one do we want to solve out for first? Let's solve out for the x component, which is having to do with the adjacent. So which one of these equations is that? Hopefully you're saying the cosine. So the cosine of the reference angle, which is 30 degrees, is equal to the adjacent, which is our x, divided by 100. Multiplying both sides of the equation by 100, we should be able to get our answer. So plug that in the calculator, make sure that you're in degree mode, not radian mode, and hopefully you'll be able to get the answer of x is equal to 86.6, and the units that we're dealing with is meters. So that's how far he's traveling in the x component, in the x direction. And we can actually even further specify this. He's moving 86.6 meters to the right, but being that it's a positive value, that is kind of our indication that he is moving to the right as opposed to the left. All right, so let's solve out for our opposite side, which is our y component. So we're going to be dealing with our sine. And sine of theta, which is our 30 degrees, is equal to the opposite, which is y, divided by 100. Once again, we multiply both sides of the equation by 100. And these two cancel out, leaving us with a value of y is equal to 50 meters. This is the way that's going to come in the calculator. It's up to you to know that it's actually going to be negative 50 meters because that negative indicates our direction. Okay, another thing that I was actually thinking about was you could go ahead and try to use this, our 86.6, as our adjacent and actually try to find our opposite using tangent. That might be interesting for you to try out and do on your own and see what you get. You should be able to get the same exact answer if done correctly. Okay, so I'm going to invite you to try out problem number 2. I'll help you set this up because I've had students in the past actually tell me that this one confused them a little bit, and I'll show you where the confusion is. So we have this rocket, it's going 40 meters per second, which is actually really fast. Think about that, 40 meters per second. So in a given second, it's going 40 meters. That's really fast at an angle of 15 degrees. So let me show you this. We have this, we have our ground over here, and we have this angle. Obviously, it's going up in this direction. This is our 40 meters per second. What really confused my students was the idea that the 15 was all the way out here, the 15 degrees. So, hey, you know what? Say if I put the degrees right in here, that's 15 degrees. Is that any bit different if I was to actually put the 15 degrees out here? Well, no, it's still on that incline of 15 degrees. What if I actually make the 15 degrees all the way out here? Does that make it any bit different? No, it's still 15 degrees. I could write it all the way out here if I wanted to, and that's still actually just showing that you're going up on an angle of 15 degrees. So I really just wanted to show you that because that did provide a lot of confusion to my students, and just note the idea that this in here is our 15 degrees, and that's the setup. So take the problem from there and try it out. Okay, yeah, try this one out. This will be a good one for you to try. The very end question, and how tall is the antenna? You have to think about that. Think about how to actually go about doing that. If you need any hints, I'll actually give a hint about that at the end of this video. Okay, so setting up this triangle over here, I'll help you out. We have, this is our 50. We have our reference angle of 60 right here. And it looks like that you're trying to solve out for the hypotenuse on this one. Okay, and this problem, this one might look a little crazy, so let's actually go through the first one or two parts of this together, okay? All right, so take a look at this. What we have here are 4 different vectors. The way that you should look at this is view them all separate from each other. If you're given a problem like this, these are just 4 completely separate vectors. What I'm going to do to indicate that is draw them separately. So we're trying to find out both of the x and y components of all 4 of these vectors. So for vector A, I'm just going to draw that over here. And this is a value of 15 with a reference angle of 60 degrees. You should be able to find out the x and y components of this by now. What about B? Looking at B, it's going to the right with a value of 10. What's the x and y components of this? What's the direction of this vector? Is it going to the left, right, up, down? Is there any up or down component of this vector whatsoever? Is it going up and down? Well, no, it's not. It's just going to the right. So what's the up and down component of this vector? 0. And what's the x component? Bam, problem done. Okay, well, what about C? How much is this vector going to the left and right? Is it going to the left and right at all? Nope. Oh, of course I wrote it in the wrong spot. And how much is this going up and down? Oh, not so fast, not so fast. What did I do wrong here? Did I indicate the direction? No, I did. Okay, and the very 4th one, the very last one. Now, I'm not doing the trigonometry. I'm leaving that to you. Okay, so that's the setup. Try to find out the x and y components, put them in the chart, and you're done with that problem. So do you need a little hint for this problem right now? If you do, feel free to watch this video. If you don't, feel free to move on. So this problem actually is saying, how high above the person's head is the roof? Okay, so what we're trying to do here is figure out how high above the person's head is the roof. Oh, we're trying to find out this height right here. So you're going to try to find out that height. So you're trying to find out what y is equal to. And then it asks you, and what about the antenna? So the height from here all the way up until the antenna, what's that height? So you're just going to find out that. All right, so you have this height from here to here. That's in the first part of the problem. And the second part of the problem is this other, what you actually have right here, And it's asking us, how tall is the antenna? Well, isn't the height of the antenna, isn't that just from here to here? So if we know that, don't we just do a subtraction? Hey, you know what? We have this value. Let's make up some numbers right now. So we have this value of 6 and this value of 9. Isn't the height of the antenna the 9 minus 6, which is equal to 3? And there you go. That's your hint.